We just spent 2 days with the team working on short gameplay prototypes with Godot 3.1. This was an exercise to prepare the upcoming platform adventure game course that we're working on, the 2D one. Each and every one of us worked on a separate project pretty freely to try to get some ideas going for the course. The constraints were to make it the quote-unquote proper way, to not use graphics from the start but focus on the game feel and the core mechanics. I tried to record the broad steps I followed to create that prototype, but also the obstacle I faced and how I could overcome them. This video is the result of this process, a collection of tips, but also a look at prototyping from a game designer's perspective. Here is my game design document for the project. It holds in 1 page of text, really, and most of it is just a few notes that are gonna go away. So I try to keep the docs as lean as possible before we make the prototype and we validate it. At first, I have a few blocks like this one, my initial notes, and these are the rough idea for the game, for the prototype. I'll generate a few of these, not just one. In this case, the one I chose is a game that tries to move just a little bit away from classic Metroidvanias, although you will see there's a similarity with Bionic Commando and Flint Hook. In the game, you can jump in the end, but the jump is not very useful. It's quite limiting, so it helps you to jump over a gap forward, but if you want to go high, if you want to move vertically, you have to use a hook, and a hook that's going to propel the character towards the target. So from there, I work either on the game's theme, the essential idea that's going to drive the entire design, or in this case, the core mechanic. It's going to be the control, the element that's going to be central to the game, and I've left a note to myself to try to make it as versatile as possible. After starting the prototype today, I was struggling with the controls, and so I thought about the game Flint Hook that I had never tried, but I wanted to see how they made it work. With the mouse, I had an idea of how to give 360 degree of freedom to the player, but it turns out that with the controller, if you try to use the right stick, it doesn't work at all. You can't reach the buttons, you have very few controls that you can use. That would be too limiting for the game, because you have both thumbs taken, and the grip you need to have on the controller makes it hard to just use it conveniently. For this prototype, I'm only going to focus on the core mechanic. One reason is that should be the center of the game, and it should be very good from the start with no graphics, etc. The other reason is that we've been mostly making videos on the channel for the past few years, and this is a full-time job. This doesn't leave me a lot of time to do game design, so I don't have the tools and the workflow set up to be as efficient as possible. It's not like I was making 20 or 30 game prototypes a year. Instead, for me, it's both a refreshing and a challenging exercise to be efficient with that. I've been preparing the state machine for the character, and overall the base of the system is there. You can hook to propel yourself in a certain direction. Right now, hook is a state, and I don't know if it should be, because it overrides the jump state, which prevents you from controlling the character mid-air. Another issue that I can see is if I switch to the Xbox controller, following the scheme that they use in Flint Hook, one of the issues that you have is controlling where the character will land and where the character will hook, and that's why they have hooking points that you can loop through, I think, in the game. The issue is you're going to hook in the direction you are moving. The main little challenge of the moment is figuring out the hook state, figuring out whether it should be a state on the character, like it is now, or a completely separate object that's going to be thrown and add a force to the character's motion. I don't know which one would work best, because you need the jump, the airborne control, and the character's movement to interact all together. And the state pattern is not the best for that, as in each state you define a different behavior that should be completely separate from the others. So you would end up duplicating the code to move the character, for example, in order to get this working. To be honest, it's been a little hard to get started today because I live right next to a busy street and I have a bit of a headache since this morning. Yeah, especially prototyping, it's one of the activities that takes the most juice for me because you have to take decisions and critical design decisions all the time. So you've got to be thinking throughout the day, and the changes can be quite fast. It's a little easier to develop a tool once you have the foundations in place because it takes a lot of the decisions for you. Once you have the critical path set, the tasks become a little easier to outline. Now we are getting into the real fun. When you start to have multiple mechanics interacting together, you start to see the bugs appear. So at this stage, I have the preservation to some extent of the character's inertia when hooking onto something, but I get this issue with the state machine where the jump and hook states don't interact too well together, so I could either separate them in the code completely, duplicate the airborne control code, and manage entering and quitting the states separately. Or one thing I want to try to solve bugs that I have right now is remove these states entirely and just have one air state where you rise and fall, and so only have the jump and the hook apply a force to the character. I'm going to try that next. Here we are a few minutes later, and removing the jump and hook states was not only easier than I thought, it only has benefits. So right now, there's only an air state, which gives you air control, and the jump and the hook, if I go back to my input function, will just change the velocity. They will apply a force to it. And as soon as you leave the floor, you are going to enter the jump state. It's actually simplified the code. I've been able to remove 2 states and a few lines of code. The other advantage is that now the hook is a separate, self-contained class that is going to handle its own cooldown, and I will try to see there how to either have it entirely manage itself, the animation, etc., or see if it needs to interact with the player, but at least now these are 2 separate classes, which helps with separation of concern. You can see that there's a bit of boilerplate for launching the hook from the hook class, so it might even not be on the character class anymore, at least the input handling. For this game, for the character, I'm using a kinematic body 2D node. A node that you use to create characters and fully control the physics or the interactions with the physics engine. This gives you access to a few methods, if I go to the docs for Kinematic Body 2D, that allow you to move the character and to get some information about the world. You have 3 methods in Godot 3.1, move and collide, move and slide, and move and slide with snap. I'm using move and slide right now, which will not only move the character, but it will resolve collisions and smoothly move the character along the ground, etc. While with move and collide, you have to code these vector transformations. You have to smooth out the motion manually. Now, one thing to note with that is when you call move and slide, which I'm doing right here on line 79, you get a vector return, which is the transformed velocity. So say you don't hit anything, your velocity will stay the same. If you hit a wall, for example, horizontally, your x velocity will become 0. So it will stop the character if you decide to integrate it into your velocity variable, which in this example I'm doing here on line 80. The thing is, it gives you those kinds of problems where you're going to try to jump on a block, and because at some point the character hits the wall here, it's going to get its velocity set to 0 and it's going to start moving only up. You won't be able to move onto the block anymore. So instead, if you want to give full control to the character, but still bounce off ceilings, for example, and get the character to stop whenever it hits the floor, you only want to integrate the slide velocity's y component into the vertical axis of your velocity vector. Now I'm using that in combination with this line. I'm always adding gravity times delta to the velocity. So there's that constant gravity pulling the character down, but because on every tick I'm using the move and slide method, when you are not moving the character on the x-axis, it's being pulled down, but there is the floor blocking it, a bit like basic Newtonian physics. The two forces cancel one another and make the character stay on the ground. But now, as I have the character properly maintaining its x velocity when it hits a wall, it's going to slide onto platforms like you can see now. If you want to add wall jump at some point, you'll have to change that, but for this prototype, it will do the trick. When it comes to drawing, I try to keep things as simple as possible, to rely on Godot as much as possible at this stage. So I use the debug option to show the collision shapes in-game, which makes it so we can see the character and the background, the environment, directly inside of the game while testing. Then for other elements, I use the drawing functions to draw circles via code, because that's the way you do it. There's a bit of code to do that for the hooking point. And for the arrow, however, it's a little more interesting. I use the built-in line 2D node. You can add that one to draw lines. Just like you would draw collision polygon 2D, you can do that and change the caps to make them round, those kinds of things. So you can create nice vector shapes with these. And if you want to draw polygon, there is a corresponding polygon 2D node that you can use to just draw colored shapes. You can change the color on that one, so you can use that to do basic vector drawing. Now, note one thing, is that I'm using the grid at all times. So I place every collision polygon, etc. on the grid. I'm using a large grid with a 40 pixel step. So this is the game at the full resolution that you're seeing there. And I'm making sure to use a number of cells to place the vertices on every collision polygon. Then for the hookable areas, or to differentiate different colliders, I use the modulate property in the visibility category, the inspector, and you can use that to multiply the color of the polygon just to make it pop a little bit. Obviously it's red by default, so it's going to be red modulated by a certain color, but at least you can differentiate them and later then add some sprites to pimp up your game. Well, right after lunch, and I finally got where I wanted the controller to be, to get started with at least. That is having the full freedom with the hook, the ability to use it multiple times with a cooldown. That's what the red target indicates, and it should indicate later if you can hook onto a surface or not. Now, the thing is, I have to think about the motion a little more. I have to give it to some people to test, do a bit of level design at this point, because as you can see, the hook pulls you towards the target, but you still move in a parabola. And if you look at Flint Hook, for example, it doesn't work the same. The hook mechanic pulls you to the hooking point, which you can go through, and it works super well in the game. It's really amazing. So I've got to see about that. I'm also experimenting with the game controller because I want the course to show how to work with the gamepad and how to support multiple control schemes. And the issue with a gamepad is that orienting the ray is really not precise. So I've tried multiple control schemes. I've tried having it on the right stick. I've tried using all 4 buttons to fire in 4 directions, regardless of where you are moving. But really, having the hook point where you are aiming the left stick is the most convenient tool here. The thing is, it makes it a bit limiting. It's really hard to orient in a diagonal. So left, right, down, and up are really the main directions that you have access to. Meaning that you will need some kind of snapping system, some help to target the right snapping location for the player. And then you need the hooking point to be more or less on the player's path for the player to feel in control, to really feel like they're moving where they're trying to go. And that's what Thin Hook does, really, but it does that with hooking points that you pass through. And if you want surfaces that you're not going to go through, I need some testing. So I'm going to add some hookable surfaces that you can pass through and see what it gives us. And soon we'll be done with this project. We'll have to make some videos, get some feedback from everyone, and to think a bit more about what we're going to teach exactly in the course, see what interesting ideas or bases for tutorials emerged from that little project. At this stage, I'm counting quite a bit on the community moving forward with the project. You know, making a platformer takes experience, and Metroidvanias are platformers at their heart. And the thing is, I'm not absolutely sure what are the best patterns to organize the code. So as you are doing it for more or less the first time, making the real thing, not just the base mechanics, you have to experiment. You have to make multiple prototypes to fail with the code and to refactor it again and again and again. One of the advantages of working with free and open source software and projects is that a developer who's got experience working on similar titles, on similar projects, can at least warn us about, one, the pitfalls that you might face, the code patterns that do not work and that you want to avoid, but also what work for them, the patterns that they find most efficient, and what works to make multiple mechanics interact. It might not be the state pattern, it might be something like behavioral deconstruction of the code, those kinds of things. At this point, I'll be fair, I'm not sure. I need some more experimentation to figure it out. Here is the final state of the early prototype. So now the hook is working as I want it to be. First, it's a lot more powerful, so it will propel the character more or less to the hooking point. I still have to figure out how to predict the movement curves of the character, and if anyone among you wants to help with that, has experience with projecting a jump or the hook, etc., projecting the forces, that'd be much welcome. It's not that I can't do it, I have some basics with Newtonian physics. It's more a matter of time and getting advice on how to do it most efficiently. The code is available in the video description, as all the prototypes we've been working on, so you are welcome to come check them. You have this new mechanic, the ability to hook through certain points. Let me jump back up on the platform. So now you can hook like that. I'm trying also to change the force of the hook based on how far you are from the hooking point, but right now it still needs some refinement. You can see the raycast between the character and the hooking point, and it's going to snap to the last hooking point. The reason is to prevent you from trying to hook onto a point through a collider. So I can hook onto the right, you can see the little target animating, but not at the bottom. You now have a few refinements in there, so you have a cooldown on the targets. You also have this big blue area that is the snapping area. If you look here on the control schemes, so right now I was using the keyboard and mouse. I also have code to when you start using the gamepad, if it wants to plug in. Replugging the gamepad, I had some issue with my microphone, and OBS picked up the computer's microphone for the next 3 minutes. Sorry for the quality. If I press a key on the gamepad, you will see that I can switch the control scheme. And so this is where this big blue area becomes very important. It's that this is what helps you find the closest target to snap onto and to make the game somewhat playable with an Xbox controller. So among the things that I would really like to refine about the controls is right now I'm increasing the air speed when the character jumps, but there's no separation between the hook and the actual just movement speed in air with the character. So it accelerates a bit when you have a direction held down and you are jumping, you are mid-air. And I would just like the hook to propel the character, to make the hook really useful and basically mandatory for the character to reach certain heights instead of, and certain lengths as well, because now you can jump over the gap like that because you can reach the maximum air speed pretty quickly, while I would like to make it necessary to use the hook to do so. Another thing is I'm trying to scale the force of the hook based on how far you are from it, so that you more or less get to jump to the hook. But right now it's using an arbitrary value, and you can see that it's not super reliable. If I jump closer to the hook, sometimes I will overshoot it quite a lot, and sometimes not so much. So I'd like to have more precise control about that, but I'm not sure how to best code it at the moment. And it's gonna be time to move to tutorials once again. So the controller, the Xbox One, works fine. I realize that the walls that you bump into might remove some freedom from the character, from the player, because you bump into them. So rails that you could go through would be nice. Then the idea is, although I could use things like jump walls, it's really not that hard to code in Godot. The thing is, I really want the player to use the main mechanic, to use the hook for as much as possible. And this would include things like when you go down and hook into a glass surface, you could crush it and go through it. That could be nice. Those kinds of things. You could pull objects, you could remove parts of walls. You could also have hooking points where these are like platforms that you can rest onto, but as you hook through them, you are going to pull them down or out of the way. So you remove obstacles, but at the same time, you make a platform fall under you. So you could use hook onto it, move to the right, I don't know exactly how, or have a pass-through platform. You hook onto it and you fall back down onto the newly obtained platforms that will fill a gap. Those kinds of things. So make the hook as versatile as possible. And if there were combat mechanics in the game, they would also rely on the hook and maybe on falling on top of enemies, a bit as in Mario. So I would think about things like, once again, using the hook into an enemy to remove its protection, but also jumping above an enemy and having to hook down onto it to propel yourself towards it and crush it, those kinds of things. And with that, we reached the end of our little prototyping session, the first one. We are going to get back to tutorials, to video production, and we are going to organize the project a little more. In the meantime, you can see the prototypes, you can test them a little bit and give us feedback. We can talk a little bit about what we are going to cover in the course, figure out some of the programming patterns that work for us, the mechanics that we could showcase. We want to move a little bit more into game design with that course, and it's quite important that we get this right. So partly doing this prototyping, for example, and trying to do it the right way, quote unquote, trying to keep the prototypes as minimal as possible, visually speaking, to nurture gameplay, to focus on the motion of the character, the controls, was a little exercise for us. I'm the kind of designer who would start with the story and the game world, for example, but I figured that this might not be what everyone wants to see and that it would be interesting to work with a different approach. With that, the prototypes are available for you to try. The code is free and open source, so you can see how everything was made. With that, you can leave your thoughts, requests, comments, etc. on the dedicated channel on our Discord server for this project in the comments below, but it's best if you come to chat with us a little bit. And that said, be creative, have fun, let's see one another in the next one. Bye bye.